Good afternoon, everybody. Do you believe in karma? Or do you believe in curse? Or bad spirits? Or revenge? What if the ghosts of dinosaurs come all the way to Earth? Or come all the way to human beings to take revenge on us? Like this. The dinosaurs, which lived 3 million years ago, are believed to be the major source of fossil fuels from which we extract natural gas and oil. Now, let's say that the curse of dinosaurs come as the bad effects of fossil fuels, which is a big threat today. So I'm going to talk about the bad effects of fossil fuels here. So one of the main deadliest bad effects of fossil fuels is the global warming and the consequent climate change. So as you could see here from this graph, it is the global temperature rise or change between 1880s and 2010. So as you could see here, there is a rapid increase or gradual increase of the global temperature from 1880 to 2010 in 30-year span. And this is a dramatic increase due to the global warming and the climate change. And right side picture, you can see a poor polar bear, which is a poor victim of the climate change and the global warming and ice melting, due to which these poor animals starve without food and they die in many numbers every year. Another problem is the pollution created in the ocean due to the oil spill in the ocean from the ships during the transport process and also oil rigs, and which kills and poisons the sea living organisms and terrestrial living organisms, and also it poisons the seafood which we eat, which is again a health problem for people. Last but not least, let's not forget the global geopolitical oil tension and war for oil resources and the connecting economical problems, which is clearly related to that. So the estimated reserve analysis shows that in 30 to 40 years, we don't have any more the natural gas or oil resources, which means that consequently the oil prices will shoot up due to the demand for the natural resources or fossil fuels in 50 years, and then in 100 years we all have to transform to vegans, and we should stop eating animals because we need animals to pull our idle cars at home, because the cars won't have any more natural gas or oils to fill the tanks. So it's time for an alternative energy source. Solar energy is one of the abundant available energy sources, which is in high production in most of the countries. But in some countries like Germany, they have surplus amount of energy production, and sometimes they also waste the energy what they produce from solar sources. And this surplus energy wasted is a clear imbalance to the energy demand from energy deficit countries. So this surplus energy or the wasted energy should be stored to balance to make a balance between the surplus energy and the energy deficiency or the energy demand in some other countries or some other domains, let's say. So we need energy storage devices. Lithium or sodium-ion batteries are one of the efficient energy storage devices. And here, as you can see here, this is in the charged state in which the lithium ions are intercalated in the negative anode material, which is graphite anode material here. And during the charge process, the lithium ions transport to the cathode part, which is the positive electron material, and parallelly the electrons are released through the external pathway, the load pathway, through which we extract current for our applications. And I work on the anode material, which is the negative electrode of the batteries. And the most commercial anode material is the graphite material, graphite anode material, which is very good in terms of very less potential, electrode potential of 0.23 volt, which means that it is it accounts to very less cell potential, and then it's very good in terms of cost as well. It's very cheap, but the disadvantage is that it has very less capacity in terms of both mass capacity and also volume capacity. So I work with tin, which has relatively higher capacity in terms of mass and also in volume, and it is relatively cheaper, and it has relatively good less potential, electron potential, which accounts to the very good cell potential as well. But we have a problem with this bulk metallic tin anode material. This experiences rapid volume expansion and contraction during the charge and discharge process, during the lithium insertion and de-insertion process, which means that this leads to the pulverization of the active mass, which consequently leads to the loss of conductivity, and then you lose capacity finally. So we have come up with a nanorattle, a core-shell setup in which the tin nanoparticles are placed inside a carbon shell with a void in between the tin nanoparticles and the carbon shell. So during the charge and discharge process, during the process of inserting and de-inserting lithium ions, during the volume expansion and contraction, these flexible carbon shells, they serve as a cushion, or they buffer the volume expansion, and they prevent the breaking of particles, and then thereby they prevent from the loss of conductivity, and they save the capacity. So let's see a small demonstration of the same. So let's assume that the green balloon is the bulk tin material. So as you saw that when you try to when it expands due to the charging process, when it expands, then it explodes at one point, which means that the particles break each other and they lose the conductivity. Now let's see what happens if we have a carbon shell. Bingo! So let's assume that the water bottle is the flexible carbon shell, and then the blue balloon is the tin nanoparticle. So as you could see here, during the charge and discharge process, during the volume expansion and contraction, it expands and contracts, and it doesn't break. So which explains that the flexible carbon shell serves as a buffer cushion to the volume expansion, and then we don't lose the capacity because we don't lose the conductivity because the particles don't break. And this is what we have achieved so far. We have the microscopy images. As you can see here, we have the nice carbon shell, and then we have the tin nanoparticles inside here as well, and also we see the carbon shell here, and then we have the void in between the tin nanoparticles and carbon shell. So in future, what I foresee is that a battery which can satisfy this loop of safety, cost, and the size. So to have a nice battery, to have a sensible battery with all conditions specified and all conditions satisfied, it should go through all the loops, and none of the three parameters can be compromised. So if you compromise one of these factors, which means that then you put weightage on the other parameter, which means that then you have to count on the other parameters a lot. So if we have to have in future, if we have to have a commercial batteries for all kind of applications in terms of energy or power or any kind of application, then we should satisfy all these conditions. So I thank our professor, Dr. Katarina Fromm, for all her support and discussions, and I thank Nampi Kwan for all for her assistance, and I thank my colleagues and the FreeMat for all mission support. And I thank Adolph Merkle Institute for the mission support as well, and then finally I thank the funding agencies as well. Thank you very much for your attention. Good afternoon, everybody. Do you believe in karma? Or curse, bad spirits, or revenge? What if the ghosts of dinosaurs come all the way to Earth and come all the way to human beings and take a revenge like this? Well, dinosaurs which lived 3 million years ago are the major source of fossil fuels from which we extract natural gas and oil. Now let's say the bad curse of dinosaurs or the bad effects of fossil fuels. So I'm going to talk about fossil fuels, the bad effects of fossil fuels. So one of the deadliest effects of fossil fuels is the global warming and the consequent climate change. So as you can see here, this graph shows the global temperature rise in 30 years from 1880s to 2010. And as you can see here, there is a rapid gradual increase of the global temperature in 30 years. And the right side you can see a poor polar bear, which is a victim of the climate change, the global warming and the ice melting, and due to this, these poor animals, they starve without any food and they die in high numbers every year. Another problem is the pollution in the ocean due to the oil spill and during the ship transport and the oil rig transport, and which kills and poisons the most sea-living animals, the sea-living organisms, the terrestrial livings, and also it impacts the food what we eat, the seafood what we eat, which also toxicates that. And last but not least, the global geopolitical tension due to the oil war and the consequent economical problem due to that. So the estimated reserve analysis shows that the fossil fuels are left not very much, and then in 30 to 40 years we won't have the natural gas and oil resources. Consequently, the fuel prices will shoot up due to the demand for oil in 50 years, and in 100 years we all should turn to vegans and we should stop eating animals, because the animals will be used to pull these the cars which apparently will not have any oil or gas to pull them. So it's time for an alternative energy source. Solar energy is one of the abundant available energy source which is in high production in most of the countries like Germany. But also in Germany, most of the they also produce surplus energy from solar energy sources, and then sometimes these surplus energy is wasted as well. Then this is clearly an imbalance between the surplus energy created and the deficient energy in some countries. So there is clearly an imbalance, and we should save the surplus energy to balance the surplus energy and the deficient energy, and for that we need some energy storage devices. Lithium or sodium ion batteries are one of the efficient energy storage devices, and here during the charge state you could see that the lithium ions are intercalated in the negative anode material, which is mostly graphite, commercial graphite anode material, and then during the discharge process the lithium ions transport towards the positive electrode, which is the cathode material, and it also parallelly releases the electrons through the load pathway, and these electrons are used as current, which can be used for some of the applications. And I work with the anode material, which is the negative electrode of the battery. So the current commercial graphite anode material is mostly graphite, which is a very good anode material in terms of low potential, that's a 0.23 volt, which means that we have very less cell potential, and then it is very cheap when compared to other anode material. But the problem with commercial graphite material is that it has very less capacity in terms of mass and also in terms of volume. So I work with tin, which has comparatively very high capacity in terms of mass and also in volume. and it is relatively cheaper, and also it has a decent low potential of 0.5 volt. But the metallic tin, which means the bulk tin, has a problem of volume expansion and contraction during the charge and discharge process, which means during the lithium insertion and lithium deinsertion process. Due to that, the active materials, the bulk tin materials, pulverize, they break each other, they lose contact with each other, and then apparently they lose conductivity and they lose the capacity. So we have come up with a tin carbon nanorattle setup, core shell setup, in which the tin nanoparticles are placed inside a carbon shell with a void in between the carbon shell and tin. And then during the lithium insertion and extraction, and during the charge and discharge process, the tin expands and contracts within the carbon shell, which is flexible, and then it survives the volume expansion. So let's see a small demonstration of the same. Boom! So here we have let's assume that the green balloon is the bulk tin material. So as you could see that during the charge or discharge, the charge process, it expands, and then at one point it breaks. And now what happens if we have a carbon shell? Super. So now let's assume that the water bottle is the carbon shell, the flexible carbon shell, and then the blue balloon is the tin nanoparticles. So now as you see that, of course it tends to expand and contract during the volume, during the charge and discharge process, but now we have a very nice carbon shell which is flexible, and then it resists the volume expansion, and then it prevents the breaking of the tin nanoparticles. So this is what we have achieved so far. So as you can clearly see that we have the formation of the nanorattle setup here. We have the carbon shell here in the temperature, and also these are the microscopic pictures. So you can see the carbon shell here and also the carbon shell here, and then you can see the tin nanoparticles inside in both the pictures, and then we can see void in between the tin nanoparticle and the carbon shell. So in future, so what I foresee personally is that we have to have a battery which can form a loop between all these factors: safety, cost, and size. So if you lose, or if you cannot satisfy one of these three parameters, then it means that you put weightage on some other parameter. Then you, for example, if you don't focus on safety, then you have to really focus on size or cost. Then you compromise one of those. So a real-time battery, a sensible battery, is a battery which can really take into account everything, and they can cope up with all these factors. And then once that is done, then we can have the best batteries which can be used for any application we decide. So I thank our boss, Professor Katarina, for all the support, and then I thank Dr. Namki Kwan for all the support and assistance. I thank my colleagues, FreeMath, for all the mission support, and I thank Adolf Merkel Institute for all the mission support as well. And then finally I support the funding agencies. And I thank you very much for your attention.